Two lines are said to be parallel if they have the same slope but different y-intercepts. That is to say that they would need to be rising and running at the same rate, which would make the slopes the same, but they would need to intersect the y-axis at different places, because if they had the same y-intercept and the same slope, they would be considered the same line, which are coinciding lines. Parallel lines do need to be different lines. So to determine if lines are parallel to each other, we do need to have them written in slope-intercept form so that we can clearly see the slope and see the y-intercept, since those are the two features that determine whether the lines are parallel. In part A here, we already have two lines that are written in slope-intercept form. Let's call the line in the top the first line and the line in the bottom the second line, so that m sub 1 refers to the slope of the first line, and the slope of the first line is the coefficient on the x term, so in this particular case it's 4. And when we compare that to the slope of the second line, we see that the slope of the second line is negative 4, and since these two slopes are not equal to each other, we would say that the lines are not parallel. In part B, we see that our two lines are written in the general form, which as a reminder is ax plus by is equal to c. So we need to solve them for y in order to write them in slope-intercept form, so that we can then see the slopes and determine whether the lines are parallel to each other. So we'll need to solve for y in the first equation and solve for y in the second equation. So let's begin by subtracting 6x from both sides, which leaves 2y on the left, negative 6x plus 9 on the right. And then when we divide both sides by 2, the 2's will cancel on the left, leaving just y. And on the right, that 2 divides into both of the terms in the numerator. So we'll have negative 6 divided by 2, which is negative 3 times x, plus we'll just leave this 9/2 as an improper fraction. This enables us to see now that the slope of this first line, we'll call it m1 again, is negative 3, the coefficient on the x to the first power. So now let's solve for y in the second equation, and we'll start by adding 3x to both sides. So we have negative y is equal to 3x plus 3. And to completely solve for y, we'll divide both sides by negative 1. The negatives then cancel out on the left, and we have y is equal to, the negative 1 needs to be divided into both terms in the numerator of the right-hand side, and we end up with negative 3x minus 3, and again, the slope of this second line is also negative 3. Since the slopes are the same, we do need to make mention of the fact that the y-intercepts are different to ensure that our lines are not the same line or not coinciding lines. So the y-intercept of the first line is the b value, or 9/2. The y-intercept of the second line is going to be 0, negative 3. So now we can say yes, the two lines are parallel.